This is a question for Cambridge IGCSE. Question number 8. The paper is given in the description. You can download and try it on. So, in the question they say ABCD is a cross section of a building. This is a cross section of a building. All the lengths are given in meters. Calculate DC. So, for this calculation, I would construct a line. Okay, so the line. I will construct a line. If I construct a line which is perpendicular to ED, this will bisect. This will divide ED into two pieces. This length will be 4 meters, and this length will be 2 meters. Why? Because this line and this line both are parallel to each other. Okay, and this is DC, and DC is also equal to the constructed line. So you can see this is a right angle triangle, so we can use Pythagoras theorem to find DC. So by theorem you can write properly. You can find 2 square plus DC square equals to 15.1 square. 15.1 square is 228.01. 2 square is 4 plus DC square. I'll write it here. So DC square is 228.01 square 228.01 minus 4, which is 224.01 DC square. We don't want DC square, we want DC, so we can take roots to both sides. The root of 224.01 is 14.96 meters. When you round it off, it can be 15 meters. So the answer you can write as 15 meters. Calculate EAB. What is EAB? EAB is this angle. I'll use a different color. This angle. So here you can use cos rule. If you don't know cos rule is easier when we consider like this. Let's say we have a triangle A. This is called a standard triangle of angles A, B and C. The opposite sides, let's assume it's A, B and C. Cos rule can be given. Cos A is equals to square of the other sides, B square plus C square minus the opposite side, A square, divided by 2 times the other sides, B, C. Similarly, here you can write cos, as this is A, let's assume this is angle A. So cos A is equals to 9 square plus 11 square minus 15.1 square divided by 2 times 9 times 11. If you solve this, you get 81 plus 121 minus 228.01 divided by 198. You can plug the values in a calculator and get the value. This is not the angle, this is the cos value of that angle. We need to find the exact value of the angle. So A is equals to cos inverse 0. Remember it's minus 0.1313. If you solve this one, you can use your calculator and get the value. You should get 97.46 degrees. The answer is 97.46 degrees. The answer in the marking scheme is given to a range of 97.46 degrees to 97.55 degrees. Next question. Calculate the cross-sectional area. Okay, this is a little bit complicated part. You have to be very careful with this. Yeah. Okay. This angle we found it's 97.55. Okay. Now, to find the cross-sectional area, you need to have the area of the triangular part plus the trapezium part. Trapezium part is easy to find because all of the data are given, but triangular part is a bit difficult. We need the perpendicular height as well as the base. Okay, we can do something like this. For the area of the triangle, half into the base is 15.1 into perpendicular height. Okay, so this is 97.5. so what will be this angle? This is perpendicular height. I can say something like this. If a line goes like this and an angle is in between, they will say this is theta. If I draw a line by closing this line, let's say the angle of the length of this line is L. The length of the line closed can be given by L cos theta. And if I draw another line perpendicular to the line I folded, this length can be given by L sin theta. So similarly, we have a line of length L, and here it is, let's assume this angle is capital B. If I were to draw a perpendicular line like this, and if I fold it to this side, it will be 11 sin B. Okay, so this line will be equal to the perpendicular height. Okay, something better than nothing. We have something now. Okay, but the problem now you have is you don't know B. You don't know what is the value of sin B. For this, you can use sine rule. Okay, let's go to this triangle again. In sine rule, what they say is, in sine rule, the concept is side over the sine of the opposite angle is equals to the side over the sine of consecutive angles in the triangle. Okay, and all of these are equals to a constant. We can name constant whatever the constant we want. It is a constant. Okay. Here we have two angles. We already know 97.15, this angle and this angle. So we can say something like this: 15 by sine rule 15.1 divided by sine 97.55 is equals to 9 over sine B. So now you can subject sine B. Sine B is equals to 9 multiplied by sine 97.55 divided by 15.1. Now you can find sine B. Use a calculator. 9 multiplied by sine 97.55. One more thing. If you have used 97.46, it's better to use 97.46 here, because the answer will be consistent. So let's take 97.46. So sine B is given as 0.5 5908. It's always advisable to use 4 digits after the decimal when you write sign values, because it's much easier if you use a log table as well. So we know the sign value, plus we know the sign value. So let's finish this equation first and then we'll substitute the sign value. Now we want to find the area of the trapezium. How to find the area of the trapezium? It's half into addition of parallel sides. This and this are the parallel sides. So 4 plus 6. 4 plus 6 into the gap. The gap we found it is 14.96 of 15. Let's take the actual value. Okay, half into 15.1 into 11 into 0.5908 plus half into 10 into 14.96. You can cut 5. Now you can simplify. This one also we cut. Yeah, let's cut. 2 divided by 2, 1. 0.5908 divided by 0.5908 divided by 2. It's 0.2954. Now you can multiply 11, multiply again it by 15.1. the answer here will be 49.065 plus 74.8. You get area 123.865 meters, not cube, meters square. 123.865 meters square. Let's go to the D equation. In D equation, they say the scale is given as 1:50, and they are asking the answer in square centimeters. So we can assume the scale is given in centimeters. So they say 1 centimeter is equivalent to 50 meters according to the scale. But in this question, we don't want centimeters and meters, we want centimeter squares and meter squares. So 1 centimeter square is equivalent to 2500 meters square. How did I get this? I squared both sides. So I can say 1 meter square is equivalent to 1/2500 centimeter square. But I don't want 1 meter, I want 123.865 meter square. So to get this, I have multiplied by 123.865. So here also we have to multiply by 123.865. But hold on, here it is in meters. If I take its meters, there is a clash of units. I need to convert this into centimeters first. So we already know 1 meter is equivalent to 100 centimeters. Similarly, 123.865 meter square can be converted to centimeters. Here we have multiplied by 100. So here also you can multiply by 100. But the problem is it's not a meter, it's a meter square. So there are 2 meters multiplied together. So we have to multiply it by another 100, which in result it gives 123.865 multiplied by 10 to the power of 4 centimeters square. Okay. So this is, we don't have to put the units in this point. Okay. If you multiply this, you will get something like this. Okay, now let's get the products. The answer is The answer is 495.446 in centimeters square. So the answer is 495.56. And that's it for this question.